Hi, welcome back. So, before the break, we were talking about the sine rule. Now, we're going to see how we can use the sine rule to find the length of a side in a triangle. Let's go to an example. Here, we're given triangle ABC, and they've given us the question that says, find the value of C. So, we need to ask ourselves, what are we given? Looking at the diagram, we can see we're given this angle, 35 degrees, this angle C, 105 degrees, and the length of this side AC, which is 14 units. So, we're given two angles and one side. The next question we're going to ask, what are we finding? So, they want us to find the value of C. This is what we need to find. We need to find a side. So, we need to find the side labeled little c, or we can call it AB, the length of AB. The next question we need to ask, remember for sine rule, we need to have one pair and one half pair. So, we need to check, do we have one pair and one half pair? Let's go back to our diagram, and if you look clearly, here's our full pair. We've got one angle and one side, and we have a half pair containing our unknown side. So, we have this side and the angle across it. So, yes, we do have one pair and one half pair. Which version of the sine rule are we going to use? Remember, there were two versions of the sine rule. Because we're looking for a side, we've got to use the version of the sine rule that has the sides on top, meaning that version, which is A over sine A, B over sine B, C over sine C. And specifically, which part of it are we going to use? Because the half pair we have is the C pair, we're going to use that piece, and the full pair we're given, which is this piece here, is the pair with the B's. We're going to be using these two parts of the equation to help us start. So, again, we're going to be using C is what we need to find over sine C, that's our half pair, and B over sine B, that's our full pair. Now, we're going to use our values in our diagram to substitute into this equation. So, angle C is 105, it goes in there. Side B has a length of 14 units, and we put that one in there. And finally, sine B and the angle B is 35, and we substitute that in. Then we'll go to our calculator. Sorry, before we get to our calculator, we first multiply throughout by sine 105. So we end up with this fraction. And all we do now is put this into our calculator. Okay, so we're going to put this right-hand side into our calculator. 14 times sine of 105 divided by sine of 35. And our answer is 23,57. But we want to round off our answer. So, if we're rounding off, we're going to end up with 23,58. And so, our value for C is 23,58. Now, there's something that we have to remember when we're dealing with triangles. When we're dealing with triangles, we have to do a kind of a checksum just to make sure that our answers make sense in the context of the problem. So let's go back to this answer that we've just got now. If you look at our diagram, 35 is less than 105. So the side across this, we expect to have a smaller value than the side across this. In other words, we expect C to be bigger in value than 14. And if you look at our answer, C is quite a bit bigger than 14. It's almost 24 units. So that's how we check to see if our answers make sense in the context of a diagram. You don't need to do this, but it's a useful tool to check. Okay, so we found one length of one of the sides. Now we're going to use the same diagram and we're going to find the other missing side. So let's go back to our diagram again. Okay, so now they want us to find the value of A. So again, it's the same diagram, so nothing's changed except what they're asking us to find. Now instead of C, we need to find A. So what are we given? Again, we've still been given two angles in one side. So we've still been given these two angles and this side. What are we finding? We're finding another side. We're finding little a, or in other words, another way we can call this line, we can call it BC. So we're finding the length of BC. Okay, to use the sine rule again, we need to check. Do we have one full pair and a half pair? Now, go back to the diagram and you'll realize our full pair is still this pair here. But we have a small problem here. Our half pair, we want to find this little a. We don't have the angle A just yet. So our first problem is to find angle A. If we did find angle A, it means we would have the half pair A and little a. Okay, so how can we find angle A? We're going to find angle A first. We'll use three angles of a triangle. Okay, but before we do that, let's just think about which version of the sine rule we're going to use again. Again, what are we finding? We're finding a side. And because we're finding a side, we're going to use the version of the sine rule that requires this, that has the sides on top. So we're going to be using this version. And because we're going to find, we're looking for little a, we're probably going to use that piece. And the full pair we're given is B and sine B. So that's the two that we are going to use. So again, let's just make sure we understand this. Because we're given the half, we've got to first find this angle A here. And when we do, we can use this half pair here. And we can use this full pair and use this equation to find our sine rule, to use our sine rule to find little a. Okay, so there's a neater version of what we're doing. We're going to say A over sine A equals to B over sine B. We're simply going to substitute first to find our A using three angles of a triangle. And because we have 105 and 35, we subtract that from 180 degrees, and we find that our angle A now has a value of 40 degrees. So we're going to use that 40 degrees in our sine equation here. Substituting, we're going to get sine over sine A, and there's the 40 we just found now, equals to B, which is 14, all over sine of 35. We're now going to multiply both sides by sine of 40, so we have a nice, neat little fraction that we can enter into our calculator here. And again, we're going to enter this into the calculator exactly as I showed you earlier. And let's see if we can do that in the calculator quickly. Okay, so now we're going to be putting this into the calculator. Let's clear that up first. So it's 14 times sine 40 divided by sine of 35. And again, remember, we're rounding off to two decimal places. So whatever the answer we get here, which is 15,6893, we're going to have to round that off. Okay, so our rounded answer, 15,69 units. Now, again, remember, we need to check if this answer makes sense in the context of our problem. In other words, check this against the angle, just as I showed you earlier. So let's go back to the board again and see if it makes sense. So this angle 40 is slightly bigger than 14. So we expect our answer, this angle 40 is slightly bigger than 35. So we expect our answer for A to be slightly bigger than 14. And if you look clearly at our answer, we've got 15,69 units, which is greater than 14. So in the context of that, we can see that our equation does look correct. Our answers do look like they make sense. And we should be on the right path. So we're finding the value of A. And we've just decided that we're going to use this version of the sine rule. We need to find A. We're going to use angle A, which we have to find first, and we're going to use B over sine B. Both of these we have. We don't have angle A yet, but we can find it. If we go back to our diagram and remind ourselves how we're going to find angle A, we have these two angles, and A is the third angle in this triangle here. So all we need to do is subtract those two angles from 180 degrees. So A will be 180 minus 105 plus 35, the sum of the other two angles. A is then equal to 40 degrees. So back to our diagram. A is now 40 degrees. Again, let's check our full pay and our half pay. Our full pay is that one. And now we have our half pay containing our unknown as well as the angle across it. So A over sine A, we have now that little piece from our puzzle, and now we're going to substitute this in. So we're going to substitute the A for 40 degrees, the angle A. B was 14 degrees, and sine of B will be sine of 35 degrees. Now, we've just got to do some algebra to complete this. We multiply both sides by sine of 40, and we end up with a neat little fraction that we've got to put into our calculator because we multiplied both sides by sine of 40. So 14 times sine of 40 divided by sine of 35. Again, let's go to our calculator and put this in. Okay, so we're going to put this fraction into our calculator. 14 times sine 40, and we need to divide that by sine of 35 equals, the answer we get on our calculator is 15,68932. And remember again, for this session, we are rounding off to only 2 decimal places. So because we've got a 689, it'll become 15,69. So A is equal to 15,69 units. Now remember, I reminded you earlier, it's very important, or it's quite useful to do a checksum to make sure that the answer you found makes sense in the context of the problem. In other words, does it fit the triangle? So let's go back to our triangle and see if our answer makes sense. Now, if we look at what we found earlier, we notice that 35, the angle 35 was across 14. And the side we found now was across angle with the angle A with the size of 40. So the angle A, sorry, let me just get my pen quickly. Angle A had a value of 40 degrees. And 40 degrees is greater than 35 degrees. And the side across 35 degrees was 14 units. So we need to check that the answer we found now is greater than 45. And if you look at our answer from here, 15,69 is greater than 15,69 is greater than 14, which means our answers do make sense. So this little tool where we do this checksum is not necessary, but it does help us to check our answers to make sure they fit within the context of the problem. It's a good way to make sure that we haven't made an error in any of our calculations. Okay, we are going to stop right here and go for a quick ad break. We'll see you at the end of that.